This video, we're going to look at some examples of solving the quadratic equation using completing the square method when leading coefficient is not equal to 1. So if you look carefully in the three examples I'm going to cover in this video, my leading coefficient is not equal to 1. It is something other than 1. So first step would be the goal is to make the leading coefficient 1. So I'm going to try to make that 7, convert the 7 into 1. How is that possible? We would divide everything on both sides with the 7 to get a 1 as a leading coefficient. That leaves me with 1 minus 2/7 y squared minus 2/7 y plus 1/7 equals 0. Most of these problems you will end up with fractions when the leading coefficient is not equal to 1. So do them extra carefully. The next step is to move the constant term to the other side. Y squared minus 2/7 y equals negative 1/7. Now we're going to cut our b in half and square it. So my b here is negative 2/7. So when I cut the b in half, this is a number I'm going to be adding to both sides. So 1/2 times negative 2/7 squared. And I can cancel the 2 and 2. So it's negative 1/7 squared, which is just going to be positive 1/7 squared because negative squared will still become a positive number. So when it's time to complete the square, bring a y in the parentheses, 1/7 in the parentheses, and sign of the middle term, square the entire parentheses. And again, don't worry, don't feel like you lost something. You started with the 3 terms and now you have only 2. You didn't really lose anything. Go ahead and FOIL this on a scratch space, y minus 1/7 squared on a side scratch space, and you will get that back. Initial, what you started with. You would get back to this expression. Okay, now on the right hand side, negative 1/7 plus 1 over 49. In order for me to add or subtract the fractions, I need to have the common denominator, so I'm multiplying top and bottom with the 7. So it comes out to be negative 7 plus 1 over 49, which is negative 6 over 49. Now it's time to do square root on both sides. Square root both sides. So y minus 1/7 plus minus square root of negative 6 over 49, which is plus minus I root 6 over 7. And lastly, the 1/7 has to go to the other side. So y is equal to 1/7 plus minus I root 6 over 7, which is 1 plus minus I root 6 over 7. If you're willing to write two separate answers, it would be 1 plus I root 6 over 7, 1 minus I root 6 over 7. Okay, next we have 3x squared minus 10x plus 5. So first step is to divide everything on both sides with a 3. That leaves me with x squared minus 10/3 x plus 5/3 equal to 0, because 0 divided by 3 is still 0. Next step is to move the constant term to the right hand side. Now on a scratch space, go ahead and cut the middle term in half and square it. That's what we're going to add to both sides. Cut the middle term in half, which is 1/2 times 10/3, and square it. Let us simplify it a little. It turns out to be 5/3 squared. Okay, again, I'm dropping the negative sign because when I square the negative sign, it will end up becoming positive. Let's complete the square. On the left hand side, we pull an x in the parentheses, 5/3 in the parentheses, and the sign of the middle term, square the whole thing. On the right hand side, negative 5 plus 25 over 9. I'm not able to add or subtract until my denominators are same. So I'm going to multiply first fraction, numerator and denominator, with a 3. Leaves me with negative 15 over 9 plus 25 over 9, which is 10 over 9. Okay, go ahead and take square root on both sides. When I do square root on both sides, we have x minus 5/3 plus minus square root of 10 over 3. And one last step is move the 5/3 to other side. So 5 plus minus square root of 10 divided by 3. We can write it as a single fraction because denominators are same. 5 plus minus root 10 over 3. Okay, next example, 3x squared minus 6x plus 2 equal to 0. So divide everything on both sides with a 3. First step is to get a 1 as the leading coefficient. And I'm going to be moving the constant term to the other side. It would become negative when it goes to the other side. Now cut the middle term in half, cut the b in half, and square it, which is just going to be 1 squared. So we add 1 squared to both sides. When it's time to complete the square, you pull an x, pull a 1, and sign off the middle term and square the entire parentheses. On the right-hand side, we have negative 2/3 plus 1, which will be negative 2 plus 3, which is 1/3. Okay, because we need the common denominator here. And 3 minus 2 is 1/3. Now, next step, it is going to be take square root on both sides. So I'm going to take square root on both sides. So when I take square root on both sides, I'm going to be left with x minus 1 on the left-hand side, but plus minus 1 over square root of 3. There's a little bit of issue over there because we're not allowed to leave square root in the denominator. We would have to rationalize, and it would become root 3 over 3. The reason why we did this is because we had a square root in the denominator, and it's a norm not to leave square root in the denominator. So now, one last step left is to move the 1 to the other side. So I have my final step here is x minus 1 equals plus minus root 3 over 3. From here, move the 1 to the other side. 1 plus minus root 3 over 3. And at this point, I can write it as a single fraction. If I go ahead and multiply the first fraction, numerator and denominator, or numerator and denominator for 1 with the 3, that will leave me with 3 plus minus root 3 divided by 3. Again, I want to warn you that you might be very tempted to cancel the 3's. Do not do that. That's a big time mistake. We've talked about it. The 3 in the numerator is not in the factored form. It's actually a part of a binomial. So don't touch that 3, okay? This is going to be our final answer. If solutions are imaginary, then the graph will be not touching the x-axis. So when you draw the graph, it could be going like this, it could be going like this, it could be going like this, or like this. It will be in one of the quadrants, or it could be touching the y-axis, but it would be not touching the x-axis at all. Okay. Now, let's look at 2 application problems. Find the rate R at which 3,000 compounded annually grows to 4320 in 2 years. So A stands for the amount, P is the principal, R is the rate, T is the time. So we want to get 4320 back, and we want to deposit 3,000, and we don't know what the rate is, so we're looking for the rate, and we want to deposit the money for 2 years. Okay. So this is your principal, this is the amount you want at the end, this is your time, and the formula is given, okay? So now go ahead and we want to solve it for R. So looks like I'm going to isolate the quantity squared first. So 4320 divided by 3,000, it is equal to 1.44. That's 1 plus R squared. So I went ahead and divided both sides with 3,000 to isolate my quantity squared. Now I'm going to square root both sides. Take square root on both sides. 1.44 square root. It is going to be 1.20 equals 1 plus R. And R would be 1.20 minus 1, which is 0.20. And if you think about in terms of percent, you need 20% interest rate to be able to, your interest rate has to be 20% to be able to give you 20% interest rate will give you the change your $3,000 to 4320 in 2 years. Okay. you want to check your answer is correct or not, you can always plug it back into the original equation on the right hand side. So 3000, 1 plus 0.20 raised to the power 2. Go ahead and figure what that turns out to be. Times 1 plus 0.20 raised to the power 2. That is equal to 4320. So that is correct. Okay. Another example. A manufacturer company has found that the demand equation for a certain type of scissors is given by equation P equals negative x squared plus 47, where P is the unit price at demand of X products. Find the demand for the scissors if the price is $11 per pair. If the price is 11, how much is the demand? So demand is the X, okay? So I'm going to subtract 47 from both sides. 11 minus 47 is negative 36 equals negative x squared. X squared comes out to be 36. X comes out to be plus and minus 6. We cannot have negative scissors. So demand is 6 scissors at the price of, when the price is $11. When the price is $11, demand is 6 scissors. When price is $11. Okay, next example. The area of circle is 36 pi square inches. Find the radius of the circle. So we know area is pi r squared. So I'm being told that the area is 36 pi. And I'm being asked to find the radius of the circle. So I plugged 36 pi for the area. And I can cancel pi on both sides. I can divide both sides with the pi. And 36 equals r squared. R comes out to be plus minus 6. And it would be plus minus 6 inches. So radius is the length, and the length cannot be negative. Again, so it would be r equals 6 inches. We are going to ignore the negative answer because the length is always positive. Okay, that's all in this video.